Assalamu alaikum students. Today's topic is polarization, and in polarization we have to talk about uh, the properties of the waves. Actually, polarization takes place only in transverse waves. Longitudinal waves cannot be polarized. So if I say that what a polarization is, then it is basically the elimination or vibration or oscillation of any particle or any field along any of the planes, or to eliminate it completely, that is called its polarization. So if we simply say that the polarization is taking place or the waves are being polarized, then it will be somehow either it will be plane polarized or completely polarized. For example, if you see that there is a slit here, I have shown you a slit, and in that slit, what did I do? I told you that, let's say, a vertically plane polarized wave is entering here. A vertically plane polarized wave is entering at this point. Then this wave will be basically entering through this slit, and that slit will cause that wave to pass through, but its intensity would be reduced. And when its intensity is reduced, you can simply say that the intensity of the wave will further vary if you just change the angle. And when you are going to change the angle, basically at that time the intensity of the wave would be further decreased and decreased and decreased. So in this way, I can simply say that it is a vertically plane polarized wave, and here the wave's intensity is decreasing. For example, here the amplitude of the oscillation or the intensity is decreasing, and so on. So here it is completely polarized. Now if I move on to the non-polarized the vertically plane polarized wave, and it is passing through a polarized screen or polarized grid, then this wave would have an intensity patterns, and those intensity patterns can be considered in this way. Let's say here there is a wave which has a sort of plane polarized pattern, and here this is actually called the transmission axis of transmission. So here this polarized, the axis of transmission is vertical, so here its axis of transmission is rotated at a certain angle with the vertical, so that is why the intensity of the wave has been reduced. And now the transmitted amplitude of the wave is at, not a naught. And when the wave is polarized vertically, yani that angle of polarization or angle of transmission is rotated to 90 degree, then there is no output wave. Did you see? There is no output wave, no output. So when there is no output, at that time, this can be described by the Milous's law. And Milous's law tells the relationship between intensity, amplitude, and angle of transmission, angle between the transmission axis and plane of polarization. So if a naught is the amplitude of incident wave, at is the amplitude of polarized wave, and theta is the angle between the transmission axis and the plane of polarization, then Milous's law is used in this way. That is at equals a naught cos theta. That is basically that law which is basic used to measure the amplitude of the transmitted wave. So here this can be simply calculated. Here, let's say I have given an example in this calculation. Let's say if there is a wave with transmitted incident amplitude a naught and cos of theta is, let's say, 0 degree, then entire amplitude will be received at the output. But if you have rotated the plane of polarization with transmission axis, the transmission axis is plane of polarization with 30 degree, then it can be calculated by using this formula. Hopefully that would be clear. Now I have given a table that at certain angles what would be the relation of amplitude, transmitted amplitude, and received amplitude. So if you see if you see, this is theta, this is transmitted amplitude, and at 0 degree all of the wave transmits outward without any polarization. For 30 degree this is the value, 60 degree, 90 degree, this is important. At 90 degree entire wave has been polarized, there is no output. Then at 180 degree you get the same as 0 degree, and at 270 degree you get same as 90 degree, and so on. So this all is basically a circular or periodic process. So in this way I have drawn a diagram for you, which is usually asked in the past paper questions, that at when the angle of polarization is rotated by 0 degree, the amplitude of intensity transmitted wave is maximum. Then for 90 degree it becomes 0. Then at 180 degree it becomes again maximum but negative. Then for 270 it becomes 0, and at 360 degree again it is maximum. So that is how we can manage the amplitude of polarized wave and the angle. The same concept is being delivered by Milos's law when we convert that concept into intensity. As you know that amplitude square is related to intensity, so by taking square on both sides of this equation, at square is equal to a naught cos square, so you got at square equals a naught square cos square theta. So that equation will transform now in it is equals to I naught cos square theta. So here whenever you have the intensity is given, you will use this equation of with squares, and when you have amplitudes given, you will use this equation without squares. So here I have given you the pattern of intensities in this table. If you see, at 0 degree when the angle of transmission is 0 degree, the entire intensity is at the output, yani you can say 100% wave is transmitted at the output. At the 45 degree, the 50% is transmitted at the output. At 90 degree 0%, yani it is called complete polarization. Okay, then again it increases for 35 degree 50%. So did you see there is a pattern again? 100% transmitted out, 50% 0, then again 0, 50, and so on. So this all varies, and here I have drawn that for you. There is one example calculation. For example, if I say that it is equals to I naught cos 30, cos 60, then what will you do? First of all, cos square is 60, so what will you do? You will do it divided by I naught into is equals to cos 60 whole square. First you will take cos theta, then you will take square of that. Remember this is a technique. First theta, yani first take theta, and then at second step take square. So you will get this relation. Now if I say that here the intensity patterns are given to you, so at this point the intensity is maximum, 100% is transmitted at the output. At a 45 degree 50% is transmitted at the output. At 90 degrees 0. Then again at 135 it is 50%, so this is 50% you can say. And then at 80 it is 180 it is maximum. It means if you rotate the plane of polarization of this polaroid, then after every 90 degree the intensity switches from maximum to 0, and from 0 to maximum, maximum to 0, 0 to maximum. It will never goes to 0 because it is intensity, so it will never be 0. So this was basically the entire game of polarization. I hope that this would be clear. In case of any concern, please write down in the comments.